It is given the next information. In this question, you will investigate curved surface areas and use calculus to derive key formulae used in geometry. Consider the straight line from the origin y is mx, where x greater or equals than 0 and less or equals than h, and mh are positive constants. When this line is rotated through 360 degrees about the x-axis, a cone is formed with a curved surface area A given by A is 2 pi integral from 0 to h y square root 1 plus m squared dx. So it is rotated by 360 degrees about x-axis, and a cone looks like this. A, given that m is 2 and h is 3, shows that a is 18 root 5 pi 2 max. So we need just calculate a given integral with given parameters. So it becomes a is 2 pi integral from 0 to 3, y it's m max square root, and m is 2, so it's 2x square root of 1 plus m squared, m is 2, so it's root 5 dx. Integral of x is x squared over 2, so it becomes 2 pi root 5 x squared, and limit 0, 3, and it's 2 pi root 5 3 squared minus 0, and it's 18 root 5 pi as required. The next B. Now consider the general case where a cone is formed by rotating the line y is mx, where x is greater or equals than 0 and less or equals than h through 360 degrees about the x-axis, and deduce an expression for the radius of this cone in terms of h and m, 1 mark, and we can see that radius is this distance, and this y coordinate of this point, it's h m, because x is equal to h, and this distance it's mh minus 0, so radius is mh. The next, deduce an expression for the slant height L in terms of h and m, 2 marks. The slant height is this distance, and just applying the Pythagoras theorem, we can see that it's a square root of h squared plus r squared, but we need in terms of h and m, and we can substitute mh for r, and it becomes square root of h squared plus m squared h squared, and it's just h square root 1 plus m squared. The next, hence, by using the above integral, shows that a is pi r l. 3 marks. Pi r l, it's a known formula for the surface area of a cone, and we need to get this result. So we just apply this formula for the surface area, and it's 2 pi integral from 0 to h, y is mx square root of 1 plus m squared dx. Integral of x is x squared over 2, so it becomes pi m root 1 plus m squared x squared, and limit 0 h, and it becomes pi h squared, this minus 0, m and root 1 plus m squared, and we need in terms of r and l, so we can see that ml is r, so let's rewrite as h m and multiplied by h root 1 plus m squared, and we can see that it's r and it's l, and we get pi r l as required. The next, consider the semicircle with radius r defined by y is square root of r squared minus x squared, where x is greater or equal than negative r and less or equal than r. And it is given the next semicircle minus r, y, x, and y is square root of r squared minus x squared. C. Find an expression for dy dx, 2 marks. So we need just find the derivative dy dx, and we can see that it looks like some function raised to some power. So we apply chain rule, we apply a rule for x to the power over half, but instead of x it will be this function, so it becomes x to the power over half derivative. It's a half x to the power over negative a half, and negative a half it's just square root in the denominator, but instead of x we write a given function, but according to the chain rule it must be multiplied by our function derivative, and we can see that r squared minus x squared derivative, it's just negative 2x, 2 cancels, and we get negative x over square root r squared minus x squared. The next, a differentiable curve y is f of x is defined for x is greater or equal than x1 and less or equal than x2, and y is greater or equal than 0 when any such curve is rotated through 360 about the x-axis. The surface formed has an area given by the next formula, 2 pi integral from x1 to x2 y square root 1 plus dy dx squared dx d. A sphere is formed by rotating the semicircle y is square root of r squared minus x squared, where x is greater or equal than negative r and less or equal than r, through 360 degrees about the x-axis. Show by integration that the surface area of this sphere is 4 pi r squared, 4 marks. So we need just calculate this integral according to this formula. So it becomes a is 2 pi, and we consider this semicircle, so we can see that x is from negative r to r, y is this curve, so it's r squared minus x squared multiplied by square root of 1 plus derivative squared, so it's this derivative squared, so it becomes x squared divided by r squared minus x squared dx. And we can see that if we make a common denominator, it becomes square root r squared minus x squared plus x squared divided by square root of r squared minus x squared dx, and it becomes 2 pi integral from negative r to r, just o square root of r squared. In general, it's r and the absolute value, but r is positive, so we just r dx. And it is equal to 2 pi, and r is constant, notice that integration with respect to x, so it's just 1 dx, so it's just x and leave r to 2 pi r, and integral of 1 dx, which is just x, and limits from negative r to r, and it is equal to 2 pi r, and upper limit minus the lower limit, and it becomes 2 pi r multiplied by 2r, so it's 4 pi r squared as required. E. Let f of x be square root of r squared minus x squared, where x is greater equals than negative r and less equals than r. The graph of y is f of x is transformed to the graph of y is f of kx. K is greater than 0. This forms a different curve called a semi-ellipse. Describe this geometric transformation. 2 marks. F of kx, its horizontal contraction by factor of k with y-axis invariant. It means every point on the curve will be k times closer to y-axis, and any point, every point on y-axis remains the same. Or it may be horizontal stretch, but by factor 1 over k with y-axis invariant. Notice that, again, contraction by factor of k or stretch by factor of 1 over k. The next. Write down the x-intercepts of the graph. Y is f of kx in terms of r and k, 1 mark. We can use the previous curve, it's f of x, and since every point becomes k times closer to y-axis, so x-intercepts become negative r over k and r over k. So we can write that plus minus r over k. Then next, for y is f of kx, find an expression for dy dx in terms of x, r, and k, 2 marks. So we need dy dx. Definitely you may substitute kx for x and calculate given derivative, but it's not necessary, because we know that if we know the derivative for a function, for example, we know that sine x derivative is cosine, and if we consider function of ax plus b, for example, sine of 10x plus 5, we apply the same formula. It will be cosine with the same argument, x plus b, but a arises in front, so it's just 10 cosine. It's just a chain rule function with more complicated argument. So we can use the previous derivative, but we should use kx instead of x, and k arises in front. It's like sine kx derivative, sine x derivative, it's cosine x, and sine of kx, it's k cosine of kx. So the previous derivative or derivative of just f of x, it was this function, this result, and k arises, so it will be negative k, and we substitute k x for x, or actually it would be useful to write that dy dx, it will be k and f derivative of kx, and it's k multiplied by, and the previous derivative, it will be more clear, negative x, so it's negative kx, and divided by square root of r squared minus kx in parentheses squared, so minus k squared x squared, and finally it's minus k squared x divided by square root of r squared minus k squared x squared. Yes, it's correct. And the next question. The semi-ellipse y is f of kx is rotated 360 degrees about the x-axis to form a solid called an ellipsoid. Find an expression in terms of r and k for the surface area A of the ellipsoid. Give your answer in the form 2 pi integral from x1 to x2 square root of p of x dx, where p of x is a polynomial for marks. So now it looks like this, minus our k, and function f of kx, which is what function, usual function f of x, it's just square root of r squared minus x squared, so function of kx becomes square root of r squared minus k squared x squared. And we need just calculate according to a given formula for the surface area, and it's what, it's 2 pi. This formula is given from x1 to x2, and we can see that it's from negative our k to our k, and y it's square root of r squared minus k squared x squared multiplied by a square root of 1 plus derivative squared. What is derivative? Derivative is this and squared, so it becomes 1 plus k to the power of 4 x squared, and just r squared minus k squared x squared dx, and it becomes 2 pi integral square root, and again make a common denominator, so it becomes r squared minus k squared x squared, r squared minus k squared x squared, plus k to the power of 4x squared dx, and we can simplify it. This square root cancels, and we get the square root of r squared plus k to the power of 4 minus k squared multiplied by x squared dx. And the next, planet Earth can be modeled as an ellipsoid. In this model, the ellipsoid has an axis of rotational symmetry running from the North Pole to the South Pole. Axis of symmetry, it means it's north-south. And the distance from the north to south is, so this distance is 12,714 kilometers, and the diameter of the equator is given, so it will be this distance. It's 12,756 kilometers. And by choosing suitable values for r and k, find the surface area of Earth in kilometers squared. Correct to 4 significant figures. Give your answer in the form a times 10 to the power of q, where a is greater or equal than 1 and less than 10, and q is positive integer for max. So we need to calculate this integral, and it becomes 2 pi and integral from this point to this point, and we can see that r over k is half of this value, so it's from negative 6357 to 6357. And what is r? We can see that if we consider given function, and when x is 0, y-intercept is just r, and it is given that distance from negative r, why is it negative r? Because it's symmetrical, it is rotated about x-axis, so this distance is also r and r, and this distance is this, so r is just a half, so r is this value divided by 2 kilometers. Oh, yes, it's r, and r over k is this value divided by 2, which is 6357 kilometers, and we can find k. So k is r divided by 6357, and r is 12,756 to, oh, it's just again 12,714, and substitute, it becomes square root of r squared. It's 6, 3, just a moment, it's 3, 7, 8 kilometers, 6, 3, 7, 8 squared plus k. We need exact value, so it will be k is this value. We need to calculate with a calculator. So let's rewrite. So it's 12,756 divided by 12,714 to the power of 4 minus the same squared x squared dx, and we just calculate it with the calculator and get the answer. So it's this value, and it's actually just k, and integral, we can use answer because instead of this, so it's 2 pi integral this value and to the power of 4 minus to the power of 4 x squared integral, and we get this result. And we need 2 4 significant figures and use the scientific notation, so it becomes 5.101 times 10 to the power of 8 kilometers squared. And that's all for this question.